Welcome, everyone, and thanks for joining us today. We're excited to give you a live look at L.B. Foster's Rockfall Monitoring, a technology that's reshaping how railroads manage safety and reliability in challenging terrain. In today's session, you'll see how our system has gone 7 years without a missed rockfall event, reduced false alarms by 99.8% compared to traditional slide fences, and given railroads back over 1,100 crew hours each year on a single 125-mile line. You can expect real trial footage, a walkthrough of the principle or operation, implementation steps, and hard operational numbers from real-world results. Leading us through the discussion is Will Becker, Product Manager of Obstacle Detection Systems at L.B. Foster. Will has spent the past 5 years at L.B. Foster working with this technology and previously spent 5 years at Norfolk Southern Railroad, bringing both supplier and Class 1 railroad experience to this work. We'll get started in just a moment, but I did want to advise that there will be a Q&A session at the end of this presentation. Please submit your questions via the Ask Questions panel at the bottom of your screen. And with that, I'll hand it over to Will.
Thank you, Hannah. Yes, so I am the product manager for obstacle detection systems at L.B. Foster over Rockfall Monitoring, and I'm excited to share with you today some of the results that we've been seeing from our Rockfall monitoring system that I think are really game-changing and bring really strong value to the system and could do the adopters of our technology. So Rockfall monitoring is really centered around a couple of key principles, and I wanted to touch on those. When we're looking at rockfall monitoring, there's really 3 places where we're driving value today. The first is in safety. Rockfall monitoring is primarily a safety product, and it's a core tenet to the system design and operation. Next is increased capacity. Compared to traditional slide fences, we're bringing home real-world results with increased capacity at all of our operators currently using rockfall monitoring today. And then finally, as a big savings in labor, taking your labor force that's working on fixing traditional slide fences and putting them back into the field to focus on other problems is a real benefit that rockfall monitoring is delivering. Now, one of the questions that I think a lot of people may have is kind of, how did we get here? What is the background? And why is L.B. Foster in this space? And so to touch on that, I wanted to go over some of our history when it comes to obstacle detection. So we're going to have to go back a little bit into 2010. L.B. Foster, for the first time, got with Network Rail in the UK and was asked to develop a system that could monitor a crossing for people or cars. And this was the first iteration of any obstacle detection system, and it became what we call our grade crossing monitoring system. The system was generally pretty well received in the UK. Network Rail, it did what they wanted to do, and it quickly expanded to over 150 grade crossings in the UK. And, there was some interest as well in Europe, especially in Germany. Now, at that time, L.B. Foster looked at this technology and thought, okay, we're a US-based company. We're based in Pittsburgh. How do we move this technology over to the US? And so we started looking around and seeing if anyone was interested in using this at a grade crossing. And at that time, the answer was mostly no. A lot of the gates in the UK were 4-quadrant gates with entry and exit gates that we were dynamically controlling. You don't see that as much in the US. But we were in this place where we had this really great obstacle detection system and really not a lot of market adoption here in the US. And so the question became, if it's not a crossing, could this technology go beyond crossings? Where can we put this kind of technology that would be impactful and beneficial to the railroads? And so we started having some open conversations with rail partners to see where they might be looking for an obstacle detection solution. Now, fast forward a couple of years, and in 2018, we had our first kind of aha moment. And we were talking to a Class 1 rail partner, and they were telling us about this big operational issue that they were getting from something called a slide fence. And so if you're in the industry, I'm sure that you are familiar with slide fences. But if you're not as familiar, It's essentially a 140-year-old technology to detect rockfall. The original slide fence was actually deployed in southwest Scotland on the Callander and Oban Railway. And essentially, it's a break wire system. The way that it was designed in Scotland was you had a tension system where these wires held up a flag. And if the wire were to break, that flag would drop and a flag would go over the track saying that you had a potential obstructed. Now, this is still the industry standard, and there really hasn't been a lot of innovation in this space. So what do I mean by that? Today, the system operates very much in the same way. There's a small current that runs through a wire, and when that wire breaks, it drops a circuit, and you know that something may have fallen onto your tracks. Now, there's plenty of downsides to this, and there's a couple of different designs. There are some people who have a high tensile fence as well, so that where the wires aren't meant to be broken. That comes with a slew of issues as well. If you have major events that happen, it can tear down your entire fence. Some people put a tilt sensor on the top of it to know that the fence has been knocked over. But essentially, one of the drawbacks is that you have a lot of false alarms, and then another is that you're not actually monitoring the tracks. You're looking for a rockfall event and hoping that it hits your fence, but you actually aren't saying if the track is clear or obstructed. But this is still the industry standard, so it's kind of the status quo of what we're delivering, what we're working with today. We really wanted to understand what the operational impact is to our customers who operate slide fences. And so we went to one customer who was having a lot of issues and looked at one single subdivision where they have heavy slide fence usage and wanted to see what the impact of the operation was. And so here's what we found. Throughout a year, they saw over 5,500 activations. This is probably one of the most active areas of slide fence in North America. Of those activations, 99.5% of them were false alarms. So you can imagine small rocks or snow and ice buildup, even things like animals. And a lot of times they don't even know what tripped the fence. But most of the time, false alarm, no rock in your tracks, and nothing to cause a concern. When you have these false alarms, though, there's some real world consequences that take place. So you can imagine the fence breaks. Well, that circuit is broken until it is repaired, and trains are slowed until it can be repaired. So it's pretty important to get your labor out there to physically repair the fence. On average, they're spending around $2,500 in labor costs to fix that fence and get their network back up and running. So they were spending over $10 million per year in just labor costs alone. And then lastly, there's operational consequences for a false detection. The railroad needs to treat it as if there was a rock on their tracks. And so trains slow, in some cases even come to a full stop. And on average, we found around 9.3 hours of network delay for every single activation, with each activation costing $21,000 on average of direct costs. That's crew starts and locomotives idling. It doesn't even take into account the capacity loss that they could be experiencing. So, right there, those numbers together are over $100 million problem, and this is one subdivision. So we realized that there was a major problem out there, and there were hundreds of miles of slide fence that are being operated throughout North America, and railroads were looking for a solution. So this was kind of our first idea that we needed to develop something to address this. And the way we did it is we made a very intentional pivot from the grade crossing monitoring system to rockfall monitoring. In doing this, we decided that we were going to take an approach with two key locations. And so you can see them below. So the first was one in British Columbia, Canada, and the second was in the Nevada desert in the United States. And we'll get into, some of the results that we saw at these locations. But the key reason for us doing this was we understood that having two different harsh environments like this, one which you're going to have the Canadian winter and all the things that come with that. The other, you're going to have the US heat of the desert and all the things that come with that. If we were able to have a system that met customer expectations at both of these places, we'd have a really robust and experienced rockfall monitoring system that we could deploy anywhere in the world with confidence. So before I get into the results of how these trial installations went, I did just want to cover how our system works a little bit. So our rockfall monitoring system works in one way. We are sending out beams, doing a full scan 20 times per second. The beams leave the LiDAR and they travel out 100 feet in either direction over a 190-degree scan with 0.25 degrees between the beams. So what that looks like is this. And you can imagine we place this next to the tracks. So what you're looking at here is the 190-degree scan field placed next to the tracks, 100 feet in each direction. So we actually get 200 feet of track coverage. And then in the graphic here, you're actually looking at a 5-degree separation between the beams. You can imagine that at a 0.25 degree separation between the beams, you'd see 20 times the number of beams on the screen. Now, I want to note that our LiDAR is looking at a lot more than just the track here. We can see the track directly in front of the LiDAR, but if you go towards the top of the picture, you see what is traditionally at a lot of our locations, the catchment basin, and then you have the rock face itself. That's the potential hazard. Now, typically speaking, a railroad will not care about the catchment basin. It's there to catch rocks, and you don't want to slow trains for rocks that fall into the catchment basin. What we do to make sure that the area that we're monitoring is relevant to the railroad is through our software, we actually limit our beams down to what we call the detection zone. And so this is the key zone where if we see something in the tracks, we're going to alarm upon. This is typically anywhere from 6 to 8 feet from track center on either side. Now, one view is really good. We can alarm off of one LiDAR, but we want to be a lot safer than that. And so what we've done is we actually take signals from multiple LiDAR to create overlapping scan zones. So around every 100 feet, we'll place a LiDAR so we get this redundant and overlapping coverage. What this means is that anywhere in the detection zone is being seen by at least 2 LiDAR and gives us a really high confidence of an obstacle's position, location, size, and duration that it was there, which we can make an informed alarm decision upon. Now, when we're looking at those 2 sites, I want to go back to the site in British Columbia and the site in the Southwest United States in the Nevada desert. When we first deployed this thing, what we deployed was a grade crossing monitoring system to do rockfall monitoring. And we had some major challenges to start. At grade crossing monitoring, you only scan the area right before the train approaches. With rockfall monitoring, you're scanning 24/7. So the amount of environmental conditions that you need to filter out and not alarm on are very high. And we found that right away. So in British Columbia, obviously snow and ice was an immediate and initial challenge. What we had to do is we implemented some heaters that ended up being on the LiDAR units themselves to keep snow and ice buildup from the lenses. And then additionally, we had to put in some advanced logic to filter through heavy snowfall and accumulation. After that, we saw other things like wildlife. At the beginning, we were getting tons of alarms from benign wildlife conditions like birds or deer or even rodents. And so the system needed to have algorithmic changes made to it to no longer alarm on those, since those are benign conditions and not really what we want to be stopping trains for. And then finally, dust and fog. In the Southwest US, we were getting massive dust storms that should cause us to go into alarm. And, we did get a little lucky here. Some of the stuff that we did for the snow and ice ended up being a powerful rejection tool that also handled dust and fog. And so in the end of this, we really felt like, we've handled snow and ice, we've handled wildlife, we've handled dust and fog. We have really great results coming from the system. The system is performing at a very high level in very tough conditions. We want to tell this story to the world. We want to let people know what kind of results we're seeing. And so what we decided was, at that time, it was time to do a trial. And so we asked one of our rail partners, can we do a head-to-head trial tied into the signaling system that we can publish, where we can see the operational results of the signaling system compared to the operational results of the Rockfall monitoring system, both tied into the signaling system. And so we can tell the story that in harsh environments, we are delivering real game-changing results. Additionally, we had learned a lot about what it takes to deploy a Rockfall monitoring system. And so at this time, we also redesigned our legacy system from the ground up to be a Rockfall monitoring system rather than a grade crossing monitoring system that had been adopted into Rockfall monitoring. Some of those changes include changing the power architecture to DC power, changing some of the infrastructure requirements to be much lower and scalable for long distances. So I did, going back to kind of the beginning, when we went to look into a trial, there were three key things that we wanted to track. We wanted to track safety, we wanted to track labor, and we wanted to track capacity. And first of all, the most important for this is safety. And I think some of the results ended up surprising us. If you remember me saying slide fences are the industry standard when it comes to rockfall, and the reason for that is not because they do such a great job at alarming correctly. It's that there's an assumption in the industry that they will catch any event. In our trial results, we actually found that they may not be as perfect as the industry has thought. So I did want to share a video that we captured of our very first event. And I did want to note that this was an event that our rockfall monitoring system captured and the traditional slide fence did not. If our system was not there, this could have been a very critical incident. So this happened in the middle of the night on August 24th of 2024. This rock, just because of how it presented, actually did slip between the two bottom slide fence wires without the wires breaking. Our system, this is something that's very easy for our system to detect. We detected this and sent an alert out to their dispatch center 45 seconds after the rock came to rest, and we're able to stop trains. I do have a second video of this incident. You'll see it in the top right corner. It's further down. But obviously, this is a very critical incident, one that's a must not miss. And I think it goes back to where I mentioned the slide fence is hoping that it catches the rock event. It's not actually monitoring the track, so it can't say for sure whether or not something has gone through it. Our system, unless we are 100% sure that the track is clear, we will say it's obstructed. And so that is a paradigm shift in how you say a track is clear, and it increases safety levels. Now, of course, I did have to include, here's the train stopped short in the morning, rock in full sunlight. And so, this would have been a big deal. And this is one of the things where rockfall monitoring is poised to greatly increase safety at the railroads. The second event I wanted to capture is one that the slide fence also did not capture, but our system did, but really highlights the ability of our system to detect any rock that is big enough to impact a train. And so this is probably the minimum size rock that we would alarm on. So this is about a month later, see this rock come down. This did not trip the fence either. It actually did make it through the wires, but it is just of that size where it would impact, it's in the envelope, the clearance envelope, and that's what our system detection zones are based upon. So we will alarm on this, and I think the proof is in the pudding. We did message the operator and let them know that this happened. They decided that it wasn't a hazard, and they ran trains through out of caution, and just big enough to be in that envelope. So that's some of the accuracy levels that we operate our system to. So I think, we've seen some really great results in safety. Our system inherently, based on its design, is going to be safer than the traditional slide fence. And I think the results have spoken to that. Next, we wanted to take a deep dive on labor, knowing that repairing these slide fences costs a lot of money. and is a lot of wasted time with the false alarm rates that they're currently at. So here's what those results look like. Throughout the year, we took our one fence that we had the trial site on and actually went to do all the adjacent fences next to it to look at what a total replacement would look like for this section of track. Now, they were spending over $728,000 per year on slide fence repair and upkeep. Now, that included a small amount for testing, but most of it was unscheduled repairs. When you look at rockfall monitoring, you're going to spend a little bit more upfront on the testing, since our testing takes somewhat more time than slide fences, but the repairs are less unscheduled. None of the repairs needed for rockfall monitoring in the trial period actually took the site down. It actually just degraded it, since we do have some redundancy built in. What those repairs are that you're looking at is we ended up losing a couple of LiDAR units to direct rockfall impacts, which at a very active slope, we would expect to see on occasion. At the end of the day, they were saving over $642,000 in labor per year when adopting rockfall monitoring over a slide fence. And then lastly, and most critically, I wanted to cover train performance. When we're looking at train performance, capacity can be a really big issue through these regions. System false alarm time on the slide fence ended up being over 5,500 hours per year. And rockfall monitoring, extrapolated to cover the entire division, is just 11 hours per year. What that means in real world terms is that 63.4% of trains that went through this section of track were delayed by a slide fence. Any given train had a 63% chance of being delayed. Rockfall monitoring, on the other hand, it was more of a 0.13% chance that a train's being delayed. Where this became really relevant is that this allowed at least 2 to 3 trains per day of increased subdivision capacity. And this is probably a low assessment. There's a major work block that's used just for slide fence maintenance that is in the morning in this area that could be eliminated. So rockfall monitoring, just from the direct delays, you're looking at 2 to 3 trains per day, but it could be even more than that. And so we're building capacity for the rail partners who choose to use this without them laying any rail. And, you know, obviously there's great value to that. One thing that I did want to point out is that if this is something that you're listening to and thinking, I'm interested in this, there are just some key assumptions that we would need to model your rail application, and it's something that we're excited and willing to do. So I did want to talk about what it takes to get to the next steps to deploy. LB Foster, if you're interested, will survey your location and we'll create a detailed proposal with all the work that we will do in an installation plan. Additionally, we put in front of you kind of some of the pieces of what an ROI would look like. If you need some help getting that internally or externally sold, we will create a detailed ROI with you to help get the project internally funded. And then finally, I wanted to mention that if there is budget concerns, this is a product that would fall under some safety grants, and safety grants are available. So, you know, I just wanted to go back to this rockfall monitoring. Its value, when you think of it, is safety, capacity, and labor, and that's what we're hoping to bring. Now, I know that there might be some questions that have come in, and I wanted to take a couple minutes to answer those.
Great. Well, we'll start with I have a few questions in here. Who owns install and maintenance?
Yeah, that's a great question. So one of the things that we're pretty good at is LB Foster has a very skilled field service team. And so if this is something that would be out of your roundhouse, we can do the installation of most of the components. Some of the civil work we would ask for either we could coordinate with a third-party contractor or we could work with a contractor of yours. But LB Foster can handle most of the installation and all of the maintenance. Alternatively, if this is something that you'd like to do, we will provide detailed installation guides and we will provide detailed operation manuals. And so those can be used if you want to self-operate, self-maintain, self-install. So we give you the options and you get the best of both worlds.
Great. We have someone wanting to know about two-track territory. Is this?
It's a great question. There's two options. So typically if you have a double track, there's two things we can do. One, we can put a system on either side of the tracks. So essentially one on each. If there is a low likelihood, or you'd be okay with the track being obstructed if a train stopped in front on the near tracks, we can place it just on one side and create two detection zones. And so it's half the hardware, but we can cover both tracks with one system.
Great. If we pick one location, how soon can you survey?
Yeah, that's a good question. So we have the ability to do surveys right away. If this is something you're interested in, you want a proposal, and you really want to understand, what the benefit could be, obviously reach out to me, reach out to Jim Daniels, who I think his contact information is on the screen, and we will get you sorted for a site survey and answer some of these questions. What will an installation look like? What will the cost be? And then what we'd ask in return is just some of the operational challenges that you're experiencing so we can best design and understand the issue that we're trying to solve.
I have a couple more here. Is this something we can scale up to multiple sites easily?
Yeah, for sure. So when it comes to multiple sites, the nice thing is that one controller can operate many sites. And so what we've seen is that we'll have these initial sites. For example, the picture on the screen right now is one site, but there's a site that's just on the tracks and further on. We've already actually scoped out that second site, how we would expand to it and run it off of one controller. The system is designed to be scalable, and there's really no limit to how far we can scale that. We can scale at any distance off of one controller. It just depends how many outputs you want and how many places you want your maintainers to have to go.
Cool. Someone wants to know here if you offer financing or phased deployment options.
Yeah, for sure. So if this is something that you're really interested in and you have some budget concerns, I think get with me, get with Jim Daniels, and what we will do is we'll scope out your site, and there are plenty of options when it comes to how we can deploy this. There are some trial arrangements that we put together to try it at a low fixed cost if it's something that you're interested in. Additionally, we can install part of the site and make sure it works for you guys, and then expand it out to larger sites. So I think we can work with both of those.
Looks like I have one last question here. Are you going to be at ARIMA this year?
Yes, I will be at ARIMA. So I will be at the booth.
Booth 1415.
Booth 1415. If you're interested in talking in person, obviously stop on by. You can also send me an email or give me a call.
Okay, that's all the questions we have for now.
Perfect. Well, I just want to thank everyone very much for taking the time to join. This has been pretty informative. I think you've learned something. I hope you've learned something new today. If you are interested, as I said, the contact information for me is on the screen. Feel free to call, send an email, and we'll get you in touch with the right person to get this scoped for your application. Thank you.